Hello everybody and welcome. My name is Herbert and today we'll be looking at Conda, or rather Miniconda, but we're going to be talking about that in just a minute here. Conda is a virtual environment and package manager, and let's have a look at what Conda or Miniconda actually is. So what is Conda? Conda is a package and environment manager which allows the creation of virtual environments. It allows to install packages and binaries. It allows to set environmental variables, settings, and more. Conda enables multiple environments. These environments are all isolated, and all these isolated environments can have different versions of packages, different variables, different settings, and more. Now in this video we're going to be talking about Miniconda. Miniconda is a lightweight installer for Conda, Python, and some dependencies. It's a lightweight version of Anaconda. It only has the essential packages, and it has access to the Anaconda repository packages by default. Now, what are the benefits of using Conda? Well, first of all, the compatibility is a big one. You can run your software on isolated environments that contain the exact packages, variables, and so forth that you need. And you can also install different Python versions so that it's compatible with your application. It's also a lot cleaner because all of your packages, variables, binaries, and so forth are not installed system-wide, so it doesn't make a mess when you install multiple packages or assign multiple variables. It also makes the entire process of developing a lot clearer and easier because it's a lot easier to differentiate between your projects since they are all in different virtual environments, which makes the entire development process a lot more streamlined. First, of course, before we start, we're running on our Ubuntu system here, and we just want to make sure that Ubuntu and Python, which will be upgraded with the upgrade as well, is upgraded to the latest version. So right now, I've already done this. So if I do Python 3-- version, we'll see that I'm already on 3.10, which is the latest version as on this date, which is the 21st of January. This is the latest version that you're going to be getting from apt. But, you know, that might change in the future. And, of course, right now, Python is already on 3.11, I believe. I don't know. I think it's still in beta, but it's definitely already at 3.11. So this is definitely not the latest version. But to really get the latest version of Python, it's a really difficult process. Or, you know, you either have to get the version from their website and compile it yourself, or you need to add something, a different repository to your repository list, and then you can get it from a different repository. But you know, it doesn't really matter all that much. We don't really need the latest version of Python for this to work. If you really need the latest version of Python, then I guess that you still need to get it somehow. But for this specific case, we really don't need the latest version of Python, because at the end of the day, Conda is going to be managing our Python binaries. And when we go over to the Conda website over here, we'll see that Conda is released with Python 3.10.8, which is a little bit above what we have, but it doesn't really make a big difference. But anyway, we're going to be going with this version here. And, you know, there's different versions. If you don't want to work with 3.10, that's fine. You can get the installer for 3.9, 8, all the way. Oops, these are the Windows installers. So you can get Python 3.10 all the way down to 3.7. I think there are older installations as well, but I don't think that you want to go with 3.6 because I don't think that it's supported anymore. So I think you're better off just getting the latest version, or, you know, if you really require a specific Python version, you can go down here and get that one. But for this video, we're going to be going with the latest version. So go ahead and copy the link address over here. Now let's go back into our virtual machine, and we're right now in our home directory, which is where we're just going to be putting this shell script. So go ahead and do wget, and then just that's not the link we want. We want copy link address, and then we'll paste that in here. So we're going to be downloading that shell script, and then we're going to be running it on our system. Okay, so we downloaded it, and now we have to run it. So let's just go ahead and do sudo bash miniconda 3 latest, which is the shell script we just downloaded. I want to do sudo because, you know, I don't like putting this in my home directory. You'll see in just a minute why we're going to do sudo. So there we go. And then we're going to do enter. Then just scroll down here and then accept this by typing yes. And now it's going to ask us where we want to install Miniconda. And by default, since we are running this as sudo, it's going to assume that we are the root user, and it's going to want to install this in the root user directory. That's not what we want. That's not really a good place to put that, because only root has access to it, and we want to make sure that everybody has access to it. Everybody should be able to read the binaries. Not everybody should be able to change anything in that directory, but everybody should be able to read that. And a perfect location for that on, let's say, Ubuntu is the opt directory, which is a location where you would install optional software, which is what Miniconda is, in my opinion. So Miniconda 3, and this is going to be the location where we're going to be installing Miniconda, or we're going to be installing Conda rather, but we're just going to be calling it Miniconda since the installer is called Miniconda. So opt /Miniconda. There we go. It's unpacking now. Also, you might have noticed that I used explicitly bash. I did explicitly say bash because the shell script, the default shell interpreter in that shell script is not bash. So you really need to define that bash in front of that script and make sure that you don't go ahead and do the usual stuff, change the permissions to make it executable and then run it with /. No, you really need to specify bash, or I haven't experimented with that yet, but you could maybe change that shell interpreter on top of that shell script. But there's some binary stuff in there, so I wouldn't mess around with that shell script too much, and I would really just run bash, run it with, bash in the command line. Now over here, it's going to ask us if we want to run conda init. We don't really want that. It's not required, but we're going to try with yes. And you'll see that it doesn't really make any difference. The reason is because the shell script is thinking that we are the root user, since we ran this with sudo privileges, it's going to be using the bashrc file in the root directory. It's going to be changing that bashrc file in the root directory. But we are not root. We are Ubuntu. Ubuntu is our username. So we want to make sure that conda init is actually executed in our directory and not in that root directory. We needed those root privileges because the opt directory, actually, if we do an ll of the root directory, the root, not the root directory, but you know what I mean, the root of the file system, we'll see that the opt has read, write, and execute for the root user, but it does not have any write permissions for anybody else. Now, it's world readable, so everybody on the system can read from that, and that's good because we just need that binary. But because our conda init was not executed for our user, we're going to need to do some trickery here. So let's go ahead and make a symlink from this opt miniconda directory, and let's create a new one in the user /bin. So that will make sure that if you don't know what a symlink is, it's basically like a shortcut. We want to put this binary here, this conda binary, in the user /bin directory, because that is where our path, or whenever your shell is looking for executables, it's going to be looking in directories that you specify in the path. And this one is not specified in the path. We could add that to the path as well, but I think it's just easier to have just a symlink that just redirects you to that directory or to that binary here. So that's what we're going to do. We're going to be getting that opt miniconda 3 inside the directory conda bin. We're going to find the binary conda, and we're going to be creating a symlink inside of the user /bin directory, and that symlink is going to be named conda. So go ahead and do that. And now we are Ubuntu, and now we can do conda init bash. And that should basically do the same things. So we see that the same conda init was executed, but now we can see that it modified our bashrc file. And that's exactly what we want to use right now. So let's do source, this one over here, so /home bashrc. And when we execute that, our shell changes a little bit. So we now have base, and this means that we are in the base virtual environment of Conda, which means that we're not really in a virtual environment yet. Well, we basically are, but we didn't create one. This is the base one. This is the default one. This is the place where you don't want to be installing packages and stuff like that, because this is like the system-wide virtual environment. It's not really meant to be installing specific packages unless you really want those packages to be available to the entire system. So we're in this base environment, but we want to switch over to a different environment, right? We want to create our own environment. Well, we can do that with Conda, create -- name, and then we can define something like Flask app. And if you don't specify this, it's basically not going to install any version of Python in your environment. So you need to say that it needs to install Python. And also we can define the version. So we're going to do something like Python equals 3.9. If you don't specify this, it's just going to, if you just do Python, it's just going to be downloading the latest version it can find. So, or installing the latest version it can find. So we run this with Python 3.9, for example, and this will create our environment. It's going to be installing a bunch of stuff here. So it's going to be installing SQLite, Python, pip, all those good things. Also, do take note that Conda does track pip packages. So if you're installing things through pip, you can perfectly do that in Conda. Conda keeps track of those packages as well. So proceed, yes. There we go. And then it says we can activate this environment by doing conda activate Flask app. Let's go ahead and do that. And now let's see here, Python -- version, which is the latest version of 3.9. And also if we do which Python, we should see that it now points to our .conda/envs, and that binary is now in our environment. And we're going to look at how we can change this directory, because by default it's over here, which is a good location, you know, it's not bad, you know, it's just a hidden location, .conda. You can't really see it. If we just do ls, we'll find this, but if we do ls -la, for example, we'll see that Conda environment is here, and we can go into that directory and find our environments over there. But, you know, we don't really need to be in there for any reason. It's just all done automatically by Conda. There's no real reason why you should be in that environment directory unless you want to change a few things later on. And so now we want to install a package. Let's just say we want to install Flask. Well, easy. Just do Conda. Because we are right now in our Flask app environment, we can do Conda install Flask. And then it will install the latest version of Flask. So let's just do yes here. By the way, you can also do something called Conda search Flask, for example. That would search the repository for Flask packages, and it will just show you a list of available packages, and those packages will include all the different versions that it has. So Flask, you can start all the way from 0.12.2 all the way up to 22.2.2.2. So if we do Conda list over here and we would grep on Flask, then we'll see that it installed indeed the latest version, which is 2.2.2. Great. Okay, so installed Flask now. Let's try to create a Flask application. Let's do vim. Let's just call it main. Or let's just call it hello.py. Hello.py. And now let's go back in this. Let's go over to this website over here, which is the Flask Quick Start, and let's just copy this here. And this is just a basic quick start, a minimal application that is on the Flask Quick Start website. And we'll just copy that in here. We press I, and then we just copy that in here. We escape, and then we write WQ to write this. And now we can run this app by doing Python -m Flask --app, and we're going to define the app, which is hello. We named it hello.py, so we're just going to call this app hello. Run, and then we define the host, so it listens on all the interfaces. If you don't do this, it only listens on localhost, and we want this to be available. We want this to be available to the internet, right? We want this to be listening on all interfaces so we can access it from outside. Let's do this, and now it's going to say, oh, this website is running over here, so we can copy that link, or we can go over here, and we should see our application, which says hello world, which is just like I said, it's a basic application. It's not really very fancy, but it's just to show you how it works. Okay, so let's quit now and let's do another Conda deactivate. And let's try to run this again. So we are in our directory and we do see this hello.py, so we know that that application is in here. So let's run that again. So let's go back here, let's copy this command again. There we go. And now it should say there's no module named Flask because that module is only installed on our virtual environment that we just created. It's not available anywhere else. Unless we would install it in this base environment, it would be available in the base environment. Now remember when I said that we can have our own Conda environments directory? First of all, we're first going to need to create one. So let's do mkdir and let's just call this Conda envs. And now we can run this command. So we can do conda config --add envs dirs. So make sure that you spell this correctly. So it's envs plural, dirs also plural. And then we're going to define the directory that we want to put this in. So we just created this directory called conda envs in our home directory. So this command should execute without any issues. There we go. And if we do now conda create --name, and we'll just call this test123, and we're just going to be doing yes here, and take note of what it said here. So environment location is going to be taking this conda/envs directory as our default directory. So if we go in here, we should see that our environment was created in this directory instead. So of course this is a very, very basic overview of how to use Conda, but it just gives you this idea of how you can really split up your environments and have different packages in different environments. And this makes it so that you can run these environments on one server and split that up into multiple applications without them interfering with each other. Now, of course, Flask was a basic application, and if you really want to run a Flask application in production, it's not going to be as easy as we did it, because you're going to be needing special servers, and you're going to be needing to specify different ports that it wants to listen to if you really want to split up these applications. But you get the general idea. You just have different virtual environments, and in these different virtual environments, you can store different packages so that you can make sure that your application runs on one specific environment, and that environment has a specific version in which you wrote that application. So when you're really writing an application, you might want to specify something. You might want to specify your packages yourself. Now, when you're developing an application, you most likely write that application in a specific version, and you want to make sure that that version is always the same. Well, the way you actually can tell Conda to use a specific version is by doing like conda install, and then you do flask equals 2.1.3, for example. You can really specify the version over here, but the easiest way to do so is by creating a requirements file. So let's go ahead and look at this requirements file that I wrote, which is in a YAML format. So we're going to be defining the name of our app, which is Flask app. And then it's going to be called dependency. And then the next key is going to be called dependencies. And then the value of that will be a list of packages you want to install. Now, this is YAML format, so make sure that you write it correctly, because this is really, really sensitive. So you want to do 2 spaces, dash a space, and then you want to define the package over here. So all the rest can be, on its own independent line. And then when you create the list underneath dependencies, you can create this list like this. And if you want to add something else down here, you want to do, again, a dash space and then another package over here. But for now, we're just going to be doing one package, and we're going to be writing and quitting that. First, need to go into conda activate flask --app flask app. Now we can run this again. I don't know if it would do it because we did specify the conda environment, but just for safety purposes, we're just going to be going into that Flask app. So conda env update -- file requirements.yaml, the YAML file we just created. Let's run that, and now we should see a lot of stuff here. And now let's do this again. Let's do conda lists, and let's do grep flask. And now we see that version 2.1.3 is installed, which is the version that we defined over here. So Conda has installed it. Now also we can do something easier. So let's do Conda deactivate. So also you can define this right from the get-go. So if you want to do Conda create -- name, and we want to do something like hello there, or like hello, just name it hello. And then we want to specify something like flask equals 2.1.3, and then Python equals 3.9, for example. That would also work perfectly fine, because we're defining the packages that should be installed right from the beginning. So right over here, we're telling it to create this virtual environment, and then also after that, we're telling it to install Flask with version 2.1.3 and Python with 3.9. And if we scroll down here, we should already see Flask is in here, and it's going to be installing Python again. So we do yes. Okay, so we're going to be doing Conda activate hello. And now we're going to be doing Conda list, grep Flask again. And that should also give us that version over here. And also Python should already be installed, Python -- version, which is 3.9.16. So that was about it for an introduction into Conda. We're going to be using this a lot. Well, I'm going to be using this a lot in my projects. So if you want to see more of these Python projects, I'm going to be doing projects with Python, with Bash, and they're all going to be focused around DevOps and system administration and things like that. So if you want to join me in those projects, then this is a very good start. Also, for Bash, for example, if you want to become a DevOps engineer or you want to become a system engineer and you want to learn more about Bash, I have a full course on the beginning basics of Bash, and there's going to be a good basis for you to start with Bash scripting. So on this channel, we're going to be doing a lot of Python scripting, some cool projects that you can do to practice your skills in DevOps and in system administration. Also maybe going to be doing some other development things. I don't know. We'll see. We'll see what we do, but definitely the focus is going to be mainly on automation and DevOps and things like that. So again, this is a good place to start. Really practice using Conda. Try to avoid using things like pip and installing system-wide packages. You really want to split those virtual environments up into different segments so that each application has its own little space, its own little virtual environment to run inside of. And that's going to give you a much better experience. And it's also going to be a good thing to practice when you really want to become a developer or a system engineer or DevOps engineer, whatever you want to call it. Having those virtual environments is really going to be crucial for you to make sure that all those applications that you're developing are running smoothly and that they are not conflicting with each other. So that's about it for me, guys. Thank you so much for watching. Again, if you want to see more of my videos and if you want to follow me with these projects that I'm going to be doing, give me a follow, give me a subscribe. Hit that like button, and thank you so much for watching, and I'll catch you in the next one. Bye-bye.